So let's have a look at range of f. To work out the range, you sketch the graph. So we need to sketch the graph of f of x. Now f of x equals 1 over x plus 1, and your domain was x is greater than 3. What does the 1 over x plus 1 graph look like? Can you please describe it in the chat? Asymptote at x equals -1. It's the reciprocal graph that is shifted to the left by 1, isn't it? So I'm going to start off with the vertical asymptote here, x equals -1. I get something that looks like that, obviously smoother in your case, but you get the gist. Now, we said x is greater than 3. There are two asymptotes I've not fully sketched here. I've also got y equals 0. And actually, I'm going to try and do a better job of this. Something like that. Now, let's say 3 is over here. Because it's saying x is greater than 3, we're going to draw an empty circle here. That height there is 1 over 4. What's the lowest height on this graph? Well, we can only have everything after to the right of that point, because x is greater than 3. So everything else I essentially want to rub off. So I don't want all of this, all of this. Would you agree with that? Any questions there? So the highest, well, the lowest height is here, and the highest height is over here. We're not including 1 over 4, and we're not including 0 either. And so what we can then say is that the range f of x is greater than 0 and less than 1 over 4. Does that make sense? Can you please let me know in the chat? Okay, so write down for range, sketch it, and then, you know, whatever other notes you need to make from this. Tell me why you didn't get it in the chat as well, so that you are aware of what you've learned. So to work out the inverse function, we said we're going to start off by doing y equals f of x, so 1 over x plus 1. And then we are going to make x the subject. So y x plus 1 equals 1, xy plus y equals 1, xy equals 1 minus y, and x equals 1 minus y over y. And then we said we'll replace x with inverse of f of x and replace y with x. So here we go. That's that done there. Right. Now, what we're going to do next to work out domain? Well, you should remember domain of inverse equals range of original. And so the domain is going to be given by, we already worked out the range in part B. X is greater than 0 and less than 1 over 4. From up here, all we're doing is replacing f of x with x. Does that make sense, and does that ring a bell? Send me your answers through if you haven't already. Your x value here, because you're putting g into f, it says x can be any real value. So your x value can be anything. Okay, that's important to understand. So fg of x, first of all, equals 1 over 8. So that's the same as saying f of 2x cubed minus 3, which is the same as saying 1 over 2 x cubed minus 3 plus 1, which is 1 over 2x cubed minus 2. And so now we can solve that equation. Sorry, squared, isn't it? One was saying cubed. Thank you for pointing that out. So 1 over 2x squared minus 2 equals 1 over 8. At this point, I would cross multiply both things to the top. So we get 8 equals 2x squared minus 2. 10 equals 2x squared. And this is 5. So x equals root 5. But because x can be any real value here, we can have plus or minus 5. Right, okay. Right, so now we are going to look at this modulus function. We're going to look at the modulus of f of x or f modulus of x functions and how this looks like when transforming graphs. So here we have got g of x equals sine x. Your range, sorry, your domain is minus 360 to 360. And part A is sketched out. We know what that looks like. It's just a wave, something that looks like this. So here's 360, here's minus 360, 0, 1, and minus 1. Now, part B is saying sketch y equals the modulus of g of x. This basically means no negative y values. Just like before, what we are going to do is we are going to highlight anything that was below the x-axis, and we are going to reflect it in the x-axis. So now when I sketch this, the bits that were positive remain positive, but the bits that had negative y values also turn positive. So that is the positive side. Now here is the negative side. Does that make sense? So now you can understand anything below the x-axis gets reflected in the x-axis. Can you write that down as some form of instruction so that you remember how to sketch that? Right, okay. Now, for part C, I'm going to sketch part g of x again quickly. Now, this was g of x. We've been asked to sketch G modulus of X. What we're going to do here is we are going to take all positive X values and reflect in the y-axis and keep it there. So Everything that has been shaded in remains there, and it also gets reflected in the y-axis. Okay, so keep all positive x values and reflect in y-axis. Okay, does that make sense? Any questions there? So looking at this, part A, just a normal quadratic, your roots are, well, if I factorize that, x minus 8, x plus 1. So my roots are x equals 8 or x equals minus 1. My y-intercept, I can read straight off from the graph, is minus 8. I have minus 1 is here and 8 is here. It's going to be symmetric, about 3.5. All right, so when I draw this, I want my lowest point there, and then from that point, I want it to keep going back up. This is x, this is y, this is minus 8. Okay, don't draw it symmetric about the y-axis because it isn't. Does that make sense? Can you please let me know in the chat? Now, that's part A done. So for part B, we are going to look at everything below the x-axis, and we are going to reflect that in here. So this point here is 8. This is still 8. This is minus 1. And I think this was okay. If I just call that 3.5, this is still 3.5. Now, part C is where you sort of get affected with it. We said we're going to keep all the positive x value parts. So for that, we are going to keep everything there. This was minus 8, and we are going to reflect that in the y-axis. This was positive 8, so this now is going to become minus 8. And you're going to need that shape. It can't be a U-shaped graph in the actual thing, because one of the marks will be for the shape and you'll lose that mark. Okay, is everyone happy with that? Can you please let me know in the chat? So, part A, I am going to highlight all the bits on the original graph that are below the x-axis. Everything above it is fine anyway. So up to C is fine, but then everything below gets reflected in it. And so this point here is going to become minus 4, 5. Just be careful to have it higher than D, because that was 3. Minus 8 is fine where it is, minus 2 is fine where it is, and E is fine where it is. So that's part A done. Now, for part B, we said everything positive we are going to keep the same. So we are going to keep this the same. This is at 2, 1. This is at 3. And we are then going to reflect whatever we've kept in the y-axis. So we get this W-shaped curve. Now this is going to become minus 2, 1. Okay, are we happy with that? If you get something like this inside the brackets, factorize out the stretch element out of both terms so that you know what the stretch scale factor is, and that then will also impact your shift. And first you'll do the stretch, then you'll do the shift. And we look at examples. When it comes to y, this outside, so for example, y combination, if we, for example, have 2f of x minus 3, we have stretch in y scale factor 2. We'll do that first, and then we will shift it by 0 minus 3. Okay, that's the order. And does that not change it from a stretch in x to y? So this is a y combination. This bit here was inside the bracket. This would just affect the x-axis. Yeah, that's fine. Right, okay, so let's look at some examples. Right, here we go. I'm going to put this up in there in Google Classrooms. Can you have a go at this and send me your answers through? If they affect x and y, if you do them, ultimately you get to the same answer. You can check it. So for part A, we have got 2f of x minus 1. Now 2 and the 1 are outside the bracket, so first we said stretch in y, scale factor 2. So first I'm going to do that. If it goes through the origin, 0 times by 2 is still going to be that. It's going to look something like this. But A now is going to have coordinates 2 minus 2. So this is 2f of x first. And I always do it in sort of 2 graphs. I won't do it in 1 graph altogether. 0 times by 2 is still going to be 0. Okay, and now stage 2 will be the shift in y. I need to shift it down by 1. So now it's going to look like this. Your y-intercept is minus 1. A now has gone to 2 minus 3. And B has gone to 6, 7. Are you happy with that? Any questions there? Okay, so that's what you should have done for part A. So this is 2f of x minus 1. Right, let's now look at part B. Part B, there are no stretches in here because they're all adding or subtracting. Well, inside the bracket, I'm going to shift left by 2. Outside the bracket, I'm going to move it up by 2. So it's translation only. I'm only moving it left by 2 and up by 2. So now, if I move every coordinate left by 2 and up by 2, A now is going to go on the, actually I better do this in 2 goes. I'll move it left by 2 first. So this is 0 minus 1. Let me just make it clear that I'm doing f of x plus 2, and this b now is 4, 4. Again, just so that you don't lose yourself. And then I've got plus 2. I need to move it up by 2. So now this is going to, oops, sorry. What was that minus 1 will now go to 1. And what was previously at a height of 4 will now go to 6. Are you happy with that for part B? Okay, so if it's just, if there's no multiplication inside or outside, it's just shifts. Okay, that's the key thing. Now, part C, you can tell that we have got 2 stretches, and because those 2 stretches affect different coordinates, it doesn't matter which order we do them in. So stretch in Y, scale factor 1/4, stretch in X, scale factor 1/2. I'll do a quarter f of x first. Get in the habit of doing it sort of step by step. Oh, that's so bad. So this point here now is 2 minus 1/4. And this point here is 6, 1. 0 divided by 4 is still 0, so it still has to go through the origin. And then now if I do quarter f of 2x, I now need to take all the x values on here and divide them by 2, or multiply them by 1/2. Origin's x value is 0, times by 1/2 is still 0, so it's still going to go through the origin. But 2 times by 1/2 is 1, so we get 1 minus a quarter here. And that point there, if I divide it, or 6 times by 1/2, I get 3 and 1. Does that make sense? Can you please let me know in the chat if you are happy with that? And you can tell that if we did it the other way around, if I did f of 2x first and then multiply the y values by 1/4, I'd still come to the same answer. So the order, if it affects different axes, does not matter. Right, D is the slightly tricky one. For this, what we need to do is factorize the 3 out inside the brackets. So now we've got 2 in the same axis. Stretch in X, scale factor 1/3. And number 2, shift in X, move to the right by 4. So first I need to do the stretch, and so I'll do f of 3x first. And so this point here is going to become 2 over 3 minus 1. This point here is going to become 2, 4. And then I'm going to do f of 3x minus 4. So I need to shift everything right by 4. So this point here is going to become 2 over 3, not 2 over 3, 4 and 2/3. And minus 1. And this is now going to become 6 and 4. So the y values have remained unchanged. This point here, which originally went through the origin, now is 4. And we can check all of these using our answers here. 4 and 2/3 is 14 over 4, by the way, so that's right. Okay, any questions there?